Hello and welcome to part 2 of our video blogs. We are answering questions from our webinar, Control Temperature Chambers, Qualification, Mapping, and Monitoring. Today, again, we welcome the presenters from that webinar, Vaisala's Paul Daniel and Validation Director from Genesis AEC, Nathan Roman. So welcome, guys. Good to see you again.
Hey, Janice.
Hi, guys.
Let's get right to the questions. So question 1, what are the recommended intervals for remapping freezers and warehouses? Paul, do you want to start?
Sure. Per the new revision of that ISP CTC guide, a resource we should all be using if we're doing temperature mapping, you read that and you'll realize this is something you get to determine yourself. You'll base that on the performance, on the history, and then the criticality of the use of the chamber. The guide even allows you to not do remapping in some situations. Personally, I've always defaulted to a 3-year rule as a starting place. Remap every 3 years. If that chamber is used for more expensive stuff or critical process, maybe you consider remapping more often. One example there would be a stability chamber, high risk. Now, if that chamber is instead, used for inexpensive, low-risk items, say just a refrigerator holding lab reagents, maybe we don't need to remap so often. We could push that out to every 5 years. But don't forget, if you're doing a warehouse, if you do need to remap, you need to remap in both summer and winter conditions.
Okay, great. Let's give this next question to Nathan. The questioner says, do you find that companies complete annual temperature relative humidity mapping studies in chambers to verify the performance following annual maintenance and calibration of the equipment? And then part 2 of the question, are these completed with a standard 24-hour study with the in situ load?
All right, so that's a good question. PM and calibration activities are typically on a 6 or a 12-month interval, but the mapping is not typically performed at that same frequency. However, I have seen yearly temperature studies done in a GLP lab, for example, but that was all based on their level of risk to do it more often than yearly. And they did couple that activity with their calibration intervals. 24-hour mapping was completed and the chambers were mapped in situ. Unless, of course, the PM requires a defrost, which then the unit would need to be emptied, as you could imagine. Typically, industry remapping frequency, like Paul said, is 3 to 5 years for CTCs. However, there is no hard, fast regulations applicable to that. New guidance is suggesting that our controlled temperature chambers should be periodically assessed to determine the need for revalidation or remapping. So, for example, like a periodic review document. The control systems, equipment, monitoring, calibration, and procedures for the units would be a part of that periodic review to ensure that the unit still operates in a qualified manner. Also, the frequency of the requalification or remapping is suggested now to be determined on result of risk assessment or when significant modifications are made to the unit. As for the items to consider during risk assessments, you can look at what is your level of risk of failure to maintain uniform temperature or storage of high value critical product or sensitive temperatures. They may warrant more frequent requalifications, revalidations. Industry practice varies, but should always be performed in alignment with your risk assessment and rationale. Everything should be determined and frequently documented.
Okay, thank you, Nathan. We'll give this next question to Paul. Is the temperature mapping always part of an operational qualification for a storage warehouse for pharmaceutical products? For example, for the storage of medications that require a cool, dry place? If yes, then how do you handle the fact that mapping should be done in summer and in winter?
Gotcha. Yeah, temperature mapping absolutely should always be part of an OQ of any storage location for pharmaceuticals. I know you're talking about a warehouse here, but whether it's a small refrigerator, a big warehouse, and you're using it for storage of pharmaceuticals, you got a temperature map in your OQ. In your case, with this definition of cool, dry place, that's pretty vague, right? You're going to have to find a way to quantify that to get some numbers on it. One place you can go to is to the USP, which defines cool as temperatures between 8C and 15C. The USP will also define dry, right? Because you're cool and dry. And they say dry is not exceeding 40% relative humidity at 20 degrees Celsius or whatever equivalent water vapor pressure at other temperatures. So there you've got a way to quantify it. So we've got this need to store something at any defined temperature, right? Whether it's cool and dry or just cold or frozen, it doesn't change the fact that in a warehouse, in something that's exposed to the outside environment, you're going to have to map in winter and summer, both. In the summer, you're challenging your cooling system, and in the winter, you're going to be challenging the other half of the system, your heating system. At least that's going to be what's happening up here in the Northern Hemisphere. But the fact that two different systems are in use in the two different seasons is why you need to map at both times of the year to make sure you maintain those conditions of cool and dry or whatever you've quantified that at.
Okay, thank you, Paul. For this last question for this video blog, let's put it out to both of you and have two perspectives. So it's a longer question. I'm a validation consultant, and my last client asked me to use the ISO 14644-1 guide, which states that the particle count sampling locations and use it as the sensor location for temperature and humidity mapping of a bulk product storage area. So 2 questions related to that. Is that justified? And is that a new industry standard? Paul, why don't you go first on this?
Well, as far as I know, there's no overlap or real relationship between the best practices for particle monitoring locations and the best practices for temperature mapping locations. They're really different. I mean, there's certainly no rule that says you can't place a mapping sensor at those locations where you would do particle monitoring, as well as all the other locations you would normally map at, simply add a few spots. But if the customer is asking that you map temperature only at the particle measuring locations and nowhere else, I don't think that's going to fly. Regardless of the best locations for particle monitoring, you need to place your temperature, humidity mapping sensors in locations that represent the area where you're going to be storing your product, the area that's temperature and humidity controlled. What's your point of view on this, Nate?
Yeah, I agree. There is no new industry standard that specifies that scenario. I would say to definitely refer to ISPE Good Practice Guide, the cold chain management, or the ISPE Good Practice Guide for the controlled temperature chambers, commissioning, qualification, and mapping and monitoring, because that will provide guidance on placing your temperature and RH sensors. You'll need to place the sensors in a uniform pattern in all 3 dimensions of your space. You'll also need to consider the potential storage locations, distance between the probes, any vulnerable areas that may be in direct path of the air or a heat source, and then any additional sensors that you suspect warm or cool areas exist, as well as the control sensors and monitoring sensors.
Yeah, and that's a lot more places than just one spot in a room or two
Right.
spots where you'd monitor particles.
Okay, great. Thank you both for both answering those questions, and thank you for joining us today for this Q&A. We're going to stop it there, but we do have another Q&A coming, so watch your email for that. Also, I'll put a link in the transcript below to our past Q&A session and also the webinar. In case you haven't seen it, you can watch it at any time. So thank you for joining us today. Thank you, Nathan and Paul.
Thanks again. See you guys soon.
Thank you.